Bismillahirrahmanirrahim. Okay, let's we continue our previous session. I think we stopped somewhere here. The previous lesson, we're still in the chapter on the topics of scope of services biomedical engineering maintenance, right? One of the tasks is you have to monitor the warranty for all the equipments, right? When the warranty starts and ends, you have a track record. And then you also have this service contract management. So you have to find out about the contracts that deals with the services provided by the suppliers for the equipments, right? So there's a need for us to monitor the contract so that you know when the contract ends, so we have a backup plan. So whether we have to renew the contract with the provider, or what we're going to do the next step. Are we going to purchase a new equipment, or are we going to still continue or purchase new equipment, or what is the plan, right? And then planning for medical equipment, so such as you have to assess the need of the biomedical equipment. So you have to conduct an assessment to find out, right, which equipment is needed, and then at utmost priority. So the one that commonly used, for example, like BPM machine, commonly used, but often also not what we call in a good condition. So you need to know how many BPM is needed in the hospital. So if we can go if you can break down, or something happens, then you know when how many backup system is needed, right? And then project management for procurement equipping. This one is more like you are in the state of buying, right? And then bidding for the price, and getting the best suppliers, best system. So you have to plan for this procurement process. Purchasing, once you have purchased, then you have to equipping. That means where is the place that we're going to use the system, and installation. So how you're going to install them. Then once you have installed them, then you have to undergo for commissioning and testing. So just to make sure the device or the system is working as been promised, right? So we don't want to buy something that before we even use it is not functioning as promised. So you have to do this commissioning and testing. And then handling over of biomedical equipment. Once you have tested, you have a commission lab, and you have done short courses. That means potentially you have to provide short courses, undergo short courses as well, so that you know how to use the system, right? Once this stage is completed, then you can hand over the biomedical equipment. Last but not least, quality assurance. Quality assurance testing for imaging equipment. So imaging equipment, there is various of them, but there's also process of quality assurance. So we need to make sure that the equipment is working and giving the desired output. The equipment is actually calibrated and is giving us the correct parameters and reading from the imaging results, imaging processes. So that's another part. Okay, right, moving on. some of the procedures that the biomedical engineering maintenance section is involved, right? This 6 is a good one, so if you can remember the 6, I think is more than enough. Responding to work requests, sometimes there is a report, right? Sometimes there is a report, so, and then there is also works that been divided among the engineers. So this request is fulfilled, there is a schedule for that. Schedule, you have to follow the timing, and then the task is completed according to the given time. Another task is you must go for routine inspection. That means the equipments in the hospitals, they already have some sort of schedule for routine inspection. That means you must regularly go for this inspection. I'm not saying that it's daily, but in a week there is a certain time is given so that you will inspect the machines, the system, whether they are working and functioning properly. Thirdly is the planned preventive maintenance. The planned preventive maintenance, you already know, I've explained before that we have to do this maintenance for equipments which is crucial, equipment which is expensive, so difficult to buy like on a yearly basis. So we better do planned preventive maintenance so that the equipment will function accordingly at all time, and the equipment also is meet the standards and giving the desired output, and is available all the time. And the problem with the expensive equipment is we cannot just simply replace them every year, right? Therefore, it is not like a normal maintenance, but we do a scheduled, planned preventive maintenance, so that with the hope that the equipment will function and will be working properly for much longer period of time. And then corrective maintenance, if there is any failures, any sort of uncalibrated system and so on, so you will be required to do this corrective maintenance, right? And then there's also emergency maintenance. So suddenly there's equipment failure in the operation theatre, so you will be called in, or in any of the wards or any of the departments. Some equipment is not working immediately, so they will call you for emergency maintenance. This one also you will have a time frame, so they will provide you with this time frame. Okay, so for the emergency maintenance, there is this time frame given. So as a BM team, we have to response in the stipulated time. Okay. Other than that, the last is the catalog update and store drawing, specification, and maintenance details. So for each system there should be some sort of reference materials, right? Specification and then drawing. So you as an engineer, anytime if something goes wrong, then you can have this drawing in front of you, so you can just open and find out which area is the one that needed for troubleshooting and so on. So the catalogs, the detailed information, specification of an equipment is really helpful, will be useful for the engineers, so that when you use them, you can do the task more easily. Okay. in the procurement. So if details out the details on the procurement, so there is maintaining tools and equipment, spare parts, uniforms, personal protective equipment, consumables, all items and chemical for maintenance services. These are under purchasing. So those are the things that fall under category of procurements. I think this one is quite easy to understand. Yeah? Right. That's it for the non-clinical services offered in Malaysia. This chapter is end, and now I have one ad hoc assignment, right? This ad hoc assignment is regarding just to see the technical knowledge and the information that you have gathered so far, right? The first one is very easy. You have to draw and design a low cost pulse monitoring system, right? Pulse monitoring system. So what is a pulse monitoring system? It's actually a system that measures the number of pulse by using the fingertip detection of bloods in the fingertip based on the reflective properties, right? So I'm not asking you to do the complete pulse oximetry system here, but I'm just asking you to do a sketch, draw and design on the pulse only. That means how the blood is passing through the fingertip and is counted in a minute. So by doing this, we can normally get the readings of a person, whether the heartbeat is 60 or 70 or 80 beats per minute, right? So your answer should consist of block diagram and then the components. That means in the block diagram you write the name. Also, what's the sensors that we use? The first potentially light dependent resistor, LDR with an LED, right? So the block diagram, you write the name and then the component. So what's the component? LDR, LED, and then the signal form. What is the signal form coming out from the LDR? So is it in the voltage? Is it in the resistance? Is it in waveform? What types of waveform? And then also declare whether it is in digital or analog, whether it's in a digital or analog form. So that's all. And then move on to the second block diagram, and then to the third, and then to the fourth. So the second, potentially the second one is what? Whether it's a voltage converter, and then the third one is amplifier. So I'm already giving you the answer, right? I think this is the idea that I want you to do: block diagram, component, signal form. Last block diagram should be the data reading, data transfer or data interface, whether you get digital or analog. So it should be in digital because we want 1010 result. So it's no longer in analog. Okay, so that is the ad hoc assignment. This one, okay, be careful, answer in one A4 paper only and do not exceed. So I don't want a very long 2 page, 3 pages, just 1 page. So this one is individual assignment. Individual, you have to do by yourself for each. So it's individual, right? Okay, now we go for the assignment. That's this the previous one is the ad hoc assignment, right? So now this one is the what we call the real assignment. Identify the detection principle in the pulse oximetry system, right? Okay, so what I ask here is your answer should include the sensor design and arrangement. So how do you position the LED and LDR? For example, how do you position the photo detectors, right? So you must be able to explain the input and output signal from the sensor to the end. Complete design of your own pulse oximetry system, which able to detect pulse only, right? This one is to detect pulse only. And which circuit is involved? Now it's going to little bit details, right? The previous one is just to get some idea, but now in this one you have to find out which circuit is involved. So just draw a small circuit, no need to write the complete circuit, right? Types of circuit, which circuit involved. So if you say a voltage converter, which type of voltage converter we can use in the pulse oximetry? That's one hint I give you. Signal type, analog or digital, I told you already. So you have to find out whether the signal is in the form of analog or digital. So if it is coming out from a LDR, so the signal is in what form? Analog or digital? Obviously it's in analog, right? So that's one hint again. And then the signal waveform, how the waveform looks like, right? From the beginning until the end. The end one obviously will be in digitals, right? Going up and down, so 1-0 signal. And then you also have to include the block diagram. So if I were you, firstly I will draw the block diagram. Okay, I will draw the block diagram, and then I will identify which are the components involved, the circuits involved, and then I will try to understand the signal coming out and insert it into the next circuits, and then to the next circuit until towards the end. Right. That's assignment 1, and this one you should take about 2 weeks time, right? You will be given 2 weeks time, right? The previous one, ad hoc assignment, is just a week from now, right? And this one, the assignment 1, this one should be in 2 weeks time. So for assignment 1, you will be doing in the group, right? In a group. So the partners, the team will be divided later. So I'll let you know who's belongs to which group, right? Who's in which group. So make sure every team do the discussion part. So you have to discuss among yourself and do the project together. And how many pages, right? How many pages? There is a question, how many pages on assignment 1? So I would suggest not more than 5 pages, right? Not more than 5 pages. That should be enough for assignment 1, group assignment. Okay, so remember, even in this assignment I requested you to find out about pulse only, right? It is still pulse only. I didn't ask you to find out the oxygen saturation, so we don't need to find out oxygen saturation. So because in pulse oximetry, as you know, from the same fingertip we can get 2 types of measurement. One is to get the number of pulse, second is to get the oxygen saturation in the blood. So for that, they have a specific sensors which can be used to penetrate the tissues in the fingers and then the bones, so that you get into the hemoglobin, the level of the redness of the blood, so that you get the oxygen concentration, right? By doing some arithmetic algorithmic programming, you'll be able to identify the oxygen level. But I'm not asking you to do the oxygen saturation. I'm just asking you to find out about the blood flow, because as our heart pump, so there is blood flow in the finger. So similarly, there is heart contraction and also relaxation. So polarization and repolarization, as you learned already in human physiology. Similarly, the blood will not continuously pumping, but there is a on and off. Through that theory, we can actually identify the pulse, the number of pulse passing through the number of pulse in the human body through the blood passing through the fingertip. So again, I remind you, just concentrate on detecting the pulse only. So don't draw for any oximetry system, just the pulse only. So okay, I think that's it. That's the explanation for assignment 1, group assignment, right? Thank you very much, and hopefully if you got any question, just ask me, and then see you in the next lesson, inshallah. Assalamualaikum warahmatullahi wabarakatuh.